Hello everyone, welcome to Physics Wallah. ನಾನು ನಿಮ್ಮ ಫಿಸಿಕ್ಸ್ ಟೀಚರ್ ಮಲ್ಲಿಕಾರ್ಜುನ್. ಇವತ್ತಿನ ಅಭಿಯಾನ್ ಬ್ಯಾಚ್ ನ ಕ್ಲಾಸ್ 11th ಅಲ್ಲಿ ನಮ್ಮ ಮೋಷನ್ ಇನ್ ಅ ಪ್ಲೇನ್ ಡಿಸ್ಕಷನ್ ನ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ರೈಟ್, ಸೊ ಬಿಫೋರ್ ವಿ ಕಂಟಿನ್ಯೂ, ರೈಟ್, ಈ ಕ್ಲಾಸಿನ ಕಂಟೆಂಟ್ ಏನೇನಿದೆ ಅಂತ ಒಂದ್ಸಲ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ರೈಟ್, ಫಸ್ಟ್ ಐ ಸಾಲ್ವ್ ಅ ಪ್ರಾಬ್ಲಮ್ ಬೇಸ್ಡ್ ಆನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಕ್ಸಿಲರೇಷನ್. ಆಫ್ಟರ್ ದಟ್ ವಿ ಲುಕ್ ಅಟ್ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್, ರೇಂಜ್ ಆಫ್ ಅ ಪ್ರೊಜೆಕ್ಟೈಲ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಈಕ್ವೇಶನ್ ಆಫ್ ಟ್ರಾಜೆಕ್ಟರಿ ಅಂದ್ರೆ ಏನು ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಅಂಡ್ ಹಾರಿಜಾಂಟಲ್ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್ ಆನ್ ಅನ್ ಇನ್ಕ್ಲೈನ್ಡ್ ಪ್ಲೇನ್ ಇದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಕೆಲವಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಈ ಟಾಪಿಕ್ ಮೇಲೆ ಇವತ್ತು ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದೀವಿ. ರೆಡಿ ಎವ್ರಿವನ್, ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್. ರೈಟ್, ವಿತ್ ದ ರಿವಿಷನ್ ಫಸ್ಟ್. ರೈಟ್, we defined position vector in 2D as r vector is equal to, right, your position vector, we defined position vector as, right, so your r1 vector, right, we defined x1 i1 y1 j cap. If you have another position vector r2, we defined it as x2 I cap plus y2 j cap. ಈ ಎರಡು ಪೊಸಿಷನ್ ಗಳ ಡಿಫರೆನ್ಸ್ ಅನ್ನು ತಗೊಂಡಾಗ ನಾವು ಅದನ್ನ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್ ಅಂತ ಕರಿತೀವಿ. ಡೆಲ್ಟಾ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು x2 ಮೈನಸ್ x1 I cap ಪ್ಲಸ್ y2 ಮೈನಸ್ y1 j cap, right, which is nothing but delta x I cap plus delta y j cap. Right, when you look at the time rate of change of this displacement vector, we call it as velocity. Right, your velocity is going to be delta x by delta t, which is nothing but the x coordinate of velocity vx I cap plus vy j cap. We also define it as delta x divided by delta t in I cap plus delta y divided by delta t in j cap. Similarly, our acceleration vector was also defined as a is equal to ax I cap plus ay j cap, which is nothing but delta square x by delta t square plus, sorry, d square x by dt square I cap plus d square y by dt square j cap. ಇಲ್ಲಿ ಇಷ್ಟೆಲ್ಲ ಬರೆದಾದ್ಮೇಲೆ ನಾವು ಈಕ್ವೇಶನ್ ಆಫ್ ಮೋಷನ್ ಅನ್ನ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಮತ್ತೆ ವೈ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಸಪರೇಟ್ ಆಗಿ ಬರ್ದ್ವಿ. ಯಾಕಂದ್ರೆ ಇಫ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಇನ್ ಅ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್, ಇಫ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಆಕ್ಸಿಸ್ ಆರ್ ಇಂಡಿಪೆಂಡೆಂಟ್, then we can treat the motion separately, right? That is why we are writing equation of motion along x and y. So x along x, vx is equal to ux plus x times t, and we have x is equal to ut plus of at square in which direction? X, so ux ax, and last one v square is equal to u square plus 2ax, all are in x direction, all the components are in x direction. Similarly, here y component, y equation of motion are going to be v is equal to u plus at, right? This is vy, uy, ay, and your y is going to be equal to uyt plus of ay t square, and last equation of motion, which is vy square is equal to uy square plus 2ay into y. These were the things we did in last class, right? Everybody on the same page, right? Let us continue our discussion with solving one problem which is based on constant acceleration, right? So they're saying a particle starts from origin with velocity v, which is equal to phi I cap. They're saying velocity is phi I cap, guys, right? This velocity is phi I. When I show the direction x, right, I don't have to write this I, right? So I don't have to write this I. You have phi meter per second in SI in x direction, right? Similarly, you have acceleration given, constant acceleration given 3i plus 2j. E vector yav direction alli ide? 3i plus 2j. Here kottiro acceleration vector 3i plus 2j li ide, right? ಈ acceleration na ನಾವು ಯಾವಾಗಲೂ ಕೂಡ ಕಾಂಪೋನೆಂಟ್ಸ್ ನಂಬರ್ ಅಲ್ಲಿ ಬರಿಬಹುದು. x I cap, ay, j cap. ಇಲ್ಲಿ ax ಏನಾಗುತ್ತೆ 3 ಆಗುತ್ತೆ, ay ಏನಾಗುತ್ತೆ 2 ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇಷ್ಟು ಕೊಟ್ಟಿರೋ ಇನ್ಫಾರ್ಮೇಶನ್ ನಾನು ಬರೆದ ಆದ್ಮೇಲೆ look at the question. What is the y coordinate of the particle at the instant its x coordinate is 84, right? Since our equations of motion are related by time, for x is equal to 84, y will be having some value, but both of them will have the same time, right? So let us try to calculate time first, right? Using equation of motion along x-axis. If I write second equation of motion along x from second equation of motion, right? So x is going to be equal to uxt plus of ax t square, right? So what is ux here? What is ux here? So your ux is, look at the velocity vector, which is 5. So ux is 5 times t, and x is given as 84 meter, right? So here of plus, right, plus of into ax ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ax ಇಲ್ಲಿ 3 ಕೊಟ್ಟಿದ್ದಾರೆ. So 3 times t square. So what is the quadratic equation going to be? 84 equal to 5t plus 1.5 t square. Guys, if you solve this quadratic equation, you are going to get the time as 6 seconds. You solve it, right? You know the Sridhar's formula, which is minus b plus or minus root b square minus 4ac by 2a. So use that formula, you get the answer. If you get t is equal to 6 seconds, let us now apply our second equation of motion along y. Y is going to be equal to uy t plus of ay t square. What is uy? Uy is 0 because initially your complete velocity is along x direction. So uy is 0. So this term is going to be 0 times, right, t plus of into ay ಏನಿದೆ, ay 2 ಇದೆ, 2 ಇದೆ, right? 2 into t square, 2 to cancel. You have y is equal to what? T square. Since t is equal to 6, your y is going to be what? Y is going to be 36, correct? At the instant when x coordinate is 84, y is going to be 36 because both of them are connected by time as the common variable, right? Okay. So, you know, when acceleration is constant, which means its magnitude will never change and direction will also never change. It's not only true for acceleration, for any vector. If your direction and magnitude both are same, it's never gonna change, right? It's never gonna change, right? Vector is not going to change. Then what is a constant acceleration, right? In general, what is a constant acceleration? Means magnitude, direction will never change. But where do we see constant acceleration in reality? We can't see constant acceleration in pretty much of the places in the universe, right? So the motion under gravity, right? When you throw a ball up in the air, the ball comes down due to gravitational force. That is equal to constant acceleration near the surface of earth, right? So those type of motion we can't consider as constant acceleration, right? So let us try to analyze the motion of an object when we throw it in air, right? So those type of motion let us analyze, right? You have a ball, you're throwing it in air, right? So what happens? See guys, you have a ball, right? You have a tennis ball on the cricket ground, you are playing with your friends, right? You throw your ball to player 1 in this direction, right? You throw the ball. To second player, you throw the ball like this. To a third person, you throw a ball like this, right? Depends on in what direction you threw, right? To whom you threw, the trajectory the ball followed, the path that the ball followed was different, right? So in this type of situation, now ಎಸಿತಾ ಇರೋ tennis ball ಅನ್ನ we call it as a projectile, that object which is thrown, right? I'll take black color. So the screen is very greeny. Let us go for a black. So your projectile body, which is an object, right? An object which is thrown, is your projectile. ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ, ಯಾವ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಲ್ಲಿ ಬಾಲನ್ನು ಎಸೆತಿದ್ಯಾ, ದಟ್ ಈಸ್ ಯೋರ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ u, ರೈಟ್? ಯಾವ ಆಂಗಲ್ ಅಲ್ಲಿ ಎಸೆತಿದ್ಯಾ ಅದನ್ನ ನಾವು ಲಾಂಚ್ ಆಂಗಲ್ ಥೀಟಾ ಅಂತ ಕರಿತೇವೆ. ಇಲ್ಲಿ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ theta, right? This launch angle is theta and the magnitude with which you throw it is your initial velocity. And acceleration due to gravity ನಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, g, which acts always downwards, right? And time of flight, right? ಇಲ್ಲಿಂದ ತಗೊಂಡು ಎಸ್ತಿದ್ ಬಾಲು ಪುನಃ ಗ್ರೌಂಡಿಗೆ ಬರಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತು ಅದನ್ನ ನಾವು ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಟಿ ಅಂತ ಕರಿತೇವೆ. ಈ ಜರ್ನಿಯಲ್ಲಿ ಎಷ್ಟು ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ನ ಬಾಲು ರೀಚ್ ಆಯ್ತು, ಎಸ್ತಿದ್ ಪ್ಯಾರಾಬೋಲಿಕ್ ಪಾತ್ ಅಲ್ಲಿ ಒಂದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ನ ಬಾಲ್ ರೀಚ್ ಆಗಿರುತ್ತಲ್ಲ, ದಟ್ ಈಸ್ ಯುವರ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ h, right? This is your maximum height h, right? This is your maximum height h. ಹಾಗೆ ಎಸ್ದಿದ್ ಬಾಲು ಸ್ವಲ್ಪ ಹಾರಿಜಾಂಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಕೂಡ ಕವರ್ ಮಾಡುತ್ತೆ. ದಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಯುವರ್ range, right? I call it as range, that is R, right? So these are the things, right, we have to be aware of, right? The terminologies I have explained, right? Now let us deep dive into the mathematics, and then we have further simplifications of mathematics, and then we jump to proper physics, what is happening here, right? So see guys, if I look at the math part of it, right? So you have a vector which is in this direction, you threw the ball in that direction with a certain velocity, so that is why you have initial velocity in this direction, right? So similarly, at any point of time you have your v velocity as a function of time. Wherever you are observing, ball will be having particular direction and magnitude at that point in this parabolic trajectory, right? So here, if this angle is theta, right, if this angle is theta, right, the velocity at any point on the trajectory can be given by who? Can be given by the tangent to this parabolic path, or the path followed by the ball at that point will give you the velocity, right? So we have velocity vector, initial velocity vector in this direction, and velocity at any point of time v of t is in this direction at this point, and in this at this point it is in this direction v of t, and at this point velocity is in this direction, right? So it's not a tangent, I wrote it wrong. Velocity is in this direction. We have different v's of t based on what t you are observing, right? So this is clear. Now I told you, in our vector analysis, every time you see a vector, you resolve it and throw away, right? You resolve it and throw away. You have a vector u and angle theta, right? You resolve this vector along x-axis. Guys, vector resolution is very simple. Theta ಇದೆ, ವೆಕ್ಟರ್ ಇದೆ, ಯಾವ ಕಡೆ ಥೀಟಾ ಇದೆಯೋ ಅದು ಯು ಕಾಸ್ ಥೀಟಾ ಆಗುತ್ತೆ. ಯಾವ ಕಡೆ ಥೀಟಾ ಇದೆಯೋ ಅದು ಕಾಸ್ ಥೀಟಾ ಕಾಂಪೊನೆಂಟ್ ಆಗುತ್ತೆ. ಯಾವ ಕಡೆ ಥೀಟಾ ಇಲ್ವೋ ಅದು ಸೈನ್ ಥೀಟಾ ಕಾಂಪೊನೆಂಟ್ ಆಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ಯು ಸೈನ್ ಥೀಟಾ. ನೌ ಐ ಹ್ಯಾವ್ ರಿಸಾಲ್ವ್ ಮೈ ವೆಕ್ಟರ್ ಗೈಸ್. ಒನ್ಸ್ ಐ ರಿಸಾಲ್ವ್ ವೆಕ್ಟರ್, ಇನಿಷಿಯಲ್ ವೆಕ್ಟರ್ ಏನ್ ಮಾಡೋದು? ತೆಗೆದು ಬಿಸಾಕು. ನೋಬಡಿ ಕೇರ್ಸ್, ಬಿಕಾಸ್ ಯು ಹ್ಯಾವ್ ದ ಸಮೇಷನ್ ಆಫ್ ಯು ಕಾಸ್ ಥೀಟಾ ಯು ಸೈನ್ ಥೀಟಾ ಗಿವ್ಸ್ ಯು ಯು, ರೈಟ್? ಸೊ ಯು ಕ್ಯಾನ್ ಥ್ರೋ ಇಟ್ ಅವೇ. ಲೆಟ್ us keep it for some good gestures, okay? Will not throw it. At this point we have v as a function of time, right? This will also have components which is vx of t, and this is vy of t, right guys? So acceleration at all the points of time, it is always acting downwards. This is your acceleration vector g acting downwards, right guys? What I have done, I have resolved the given vectors, the vectors I have observed, into x and y, because I want to treat the motion independently, right? We now can treat motion in x and y without the sense of vectors. Never ever I am going to write vector symbol again, because I know that x and y can be treated independently. So I go back to treating them as just plus and minuses. Clear? Because your x and y are independent. Guys, along x axis I resolve the component. X axis u is going to be u cos theta, right? And y axis it is going to be u sin theta, right? Acceleration along x axis, is there any acceleration? Earth always pulls down, it doesn't push you. Acceleration along x is going to be 0. Acceleration along y is going to be g, but it is in negative direction. This is plus and minus, so it is going to be minus g in downward direction. So your vx of t at any point of time can be given by first equation of motion, which is ux, which is ux plus ax t, but this ax t is 0, so your vx is just equal to vx at any point of time, right? Vx as a function of time is just equal to ux, which means our vx never changes. Vx is going to be constant because your ux is not having any acceleration. X directionally ಯಾವುದೇ acceleration illa. All the points ಅಲ್ಲಿ velocity constant. If you look at vy ಗೆ first equation of motion apply ಮಾಡಿದ್ರೆ uy plus ay t, right? What is uy? You have u sin theta minus g times t. This is your vy as a function of time. Correct guys? Right. So this simplification is done. ಕೊಟ್ಟಿರೋ ವೆಕ್ಟರ್ ನಾನು ರಿಸಾಲ್ವ್ ಮಾಡಿ ಬಿಸಾಕ್ದೆ. I told you again, I'm not going to use vector sign, only plus and minus. Now on x and y axis you have plus and minuses, right? So let us continue. What do I do now guys? So there are so many things to calculate. In a projectile motion ಯು ಲುಕ್ ಅಟ್ ಟಿವಿ, ನೀವು ಕ್ರಿಕೆಟ್ ನೋಡ್ತಾ ಇರ್ತೀರಾ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟು ಒಬ್ಬ ಪ್ಲೇಯರ್ ಎಷ್ಟನ್ನ ಒಂದು ಸಿಕ್ಸ್ ಹೊಡೆದಾಗ ಆ ಬಾಲ್ ಎಷ್ಟು ಎತ್ತರ ಹೋಯ್ತು, ಎಷ್ಟು ದೂರ ಹೋಯ್ತು, ಎಷ್ಟು ಟೈಮ್ ಇಂಪ್ಯಾಕ್ಟ್ ಆಯ್ತು, ಎಲ್ಲ ಮಾಹಿತಿನ ಕೊಡ್ತಾರೆ. ಹೌ ಡು ದೇ ಕ್ಯಾಲ್ಕುಲೇಟ್? ದೇ ಹ್ಯಾವ್ ದೀಸ್ ಫಂಡಮೆಂಟಲ್ ಥಿಂಗ್ಸ್ ಗೋಯಿಂಗ್ ಆನ್ ಬಿಹೈಂಡ್, ರೈಟ್? ಸೊ if I want to calculate the time of flight, what is time of flight? ಎಸ್ದಿದ್ ಬಾಲು ಆ ಕಡೆ ರೀಚ್ ಆಗೋಕೆ in a horizontal, right, in a ideal case without air resistance, ಎಸ್ದಿದ್ ಬಾಲು ಅಲ್ಲಿಗೆ ರೀಚ್ ಆಗೋಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತು ಅದನ್ನ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಇಲ್ಲಿ ಆರಿಜಿನ್ ಇಂದ ಎಸ್ದಿದ್ ಬಾಲು ಪ್ಯಾರಾಬೋಲಿಕ್ ಟ್ರಾಜೆಕ್ಟರಿನ ಫಾಲೋ ಮಾಡಿಕೊಂಡು ಏನ್ ಮಾಡ್ತಾ ಇದೆ, ಪಾಯಿಂಟ್ ಇಸ್ ಕಮಿಂಗ್ ಹಿಯರ್, ರೈಟ್? ಸೊ I want to know how much of time has been consumed in this process of going from here to here for the ball, right? What do? We apply equation of motion along y-axis from first equation of motion. What is first equation of motion? Which is Vy equal to Uy plus Ayt. What is Vy? Vy, guys, what I'm going to do is I'm just going to split this time of flight going from here to here through this point into two journeys. Journey 1, right, going up, this is your journey 1, right, and journey 2 from this point to coming down, right? So this is your journey 2. So here what I'm doing is I'm applying your first equation of motion from O to topmost point, right? O to topmost point, apply it from O to topmost point, right? So if I do that at the topmost point, what is the velocity in y direction going to be? 0, because ball is not going up further. If it had Vy, it would have moved even further up, right? It is not going up at the topmost. Vy is going to be 0 at the topmost. So that is why your V, right, y which is 0 is equal to Uy ಏನಿದೆ, Uy U sin theta ಇದೆ, right? So U sin theta and here Ay ಏನಿದೆ, Ay G ಇದೆ minus direction ಅಲ್ಲಿ, so it is Gt, right? So your time is going to be what? U sin theta by G. But our time of flight ಏನಿದೆ, time of flight, right, time of flight is actually what? The time taken to go up and the time taken to come down. Time taken to go up, we call it as time of ascent, and time taken to come down, we call it as time of descent. Since it is ideal case, since these two parts are, right, symmetric, right, time taken to go up and time taken to come down both are same. So I can write time of flight T is equal to T plus T, which is time of ascent plus time of descent, so which is just equal to 2T. Guys, here I have T as U sin theta by G. Substitute here, you get the time of flight as 2U sin theta by G. That's all. Our time of flight is known. ಅಲ್ಲಿಂದ ಎಸ್ತಿದ್ ಬಾಲು ಇಲ್ಲಿಗೆ ವಾಪಸ್ ಬರಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ? 2U sin theta by G. This is the expression for time of flight, right? Time of flight ಆಯ್ತು. ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಏನ್ ರೀಚ್ ಆಗುತ್ತೆ ಎಸ್ದಿದ್ ಬಾಲು, ರೈಟ್, ಎಷ್ಟು ಎತ್ತರಕ್ಕೆ ಹೋಗುತ್ತೆ, ರೈಟ್? ಒಂದು ವೆಲಾಸಿಟಿ ಯು ವಿತ್ ಥೀಟಾ ಎಸ್ದಾಗ ಎಷ್ಟು ಎತ್ತರಕ್ಕೆ ಬಾಲ್ ಹೋಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಮತ್ತೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಅದನ್ನ ನಾವು ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಅಂತೀವಿ. ಸೊ ಇಫ್ ಯು ಅಪ್ಲೈ ಥರ್ಡ್ ಇಕ್ವೇಶನ್ ಆಫ್ ಮೋಷನ್ ಅಲಾಂಗ್ y axis, right, v square is equal to u square plus 2as, right, which is in y direction. So all the components are going to be y. What is Vy at the topmost point? Vy is equal to 0. What I'm doing, applying your third equation of motion from here to the topmost point, right? Guys, you can write from O to topmost, right? Where are we applying it from? Initial and final point, both of them have to be there. Your Vy is going to be 0. Uy, U sin theta, so it's going to be U sin theta square plus 2 into acceleration is downward direction, right? So it is minus G and displacement is in upper direction. Why? Particle was here, moved up in y axis, so we will write y as plus h, which is maximum height, right? I call this distance as h, right? So this is your maximum height, right? So here from this one, if you send this term to that side, so 2g h is simply going to be u square sine square theta, right? I send 2g down, so h is simply going to be u square sine square theta by 2g. We got the answer, right? Time of flight is done and maximum height is also done, right? The next thing is calculating horizontal range, right? How much distance it covered along x-axis along with this motion, how much distance did it cover in x direction, right? So how do we do that? So what we do is we have u cos theta covered, right, in a certain time along x-axis, that is your horizontal range, right? Along x-axis alli second equation of motion apply ಮಾಡೋಣ, which is equal to v square is equal to, second equation of motion, x is equal to u t plus of a t square in x and x directions, right? So your x is going to be what? The particle is going from here to here, right? This is your x going to be capital R. So capital R is going to be ux is u cos theta, right? U cos theta, and t is time of flight, right? The particle went from this point to this point. It is the total time taken, which is nothing but time of flight, right? Plus of ax, in x direction acceleration illa, so ax is 0, right? Ax is 0. So 0 times t square, 3t square, whatever, it does not matter. So you have t from our time of flight, which is equal to 2u sin theta by g, right? If I substitute that here, so your r is going to be u cos theta times, right? U cos theta times, right, 2u sin theta by g. Guys, 2 sin theta cos theta is nothing but sin 2 theta, so it's going to be, why? Because here, why? Because 2 sin theta cos theta is equal to sin 2 theta. So you can use that identity here, and u times u is u square sin 2 theta by g. We got the expression for range, right? So expression for range is nothing but r into, r is equal to ux times t. Ux is u cos theta times the time of flight. We could have directly done r is nothing but ux times t, which is ux is u cos theta times time of flight. We could have directly written that 2 u cos theta sin theta by g, but there are 2 u's, which is u square, right? So we could have done that directly, right? So using second equation of motion, we did that, right? So all that is clear. Time of flight, maximum height, range are clear. Now look at the equation of trajectory, right? So what is the equation of trajectory? You threw the ball from the origin, right? At any point of time, you ask, where is the ball, right? You have a particular mathematical equation. If you give me the value of time, I'll give you the value of coordinates, which is x and y. That is your equation of trajectory. So how do we derive that equation of trajectory? I'll tell you. Along x-axis from second equation of motion. What is your second equation of motion? X is equal to ux t plus of x t square, right? So what is ax t? Ax in this direction is going to be 0. This term is directly 0. So your t is going to be x divided by ux, which is nothing but x divided by u cos theta, right? You have time. Now look at along y axis, apply second equation of motion. Y is going to be uy t plus of ay t square, right? So along y you are looking at, so your y is going to be, right, ui is what? Ui is nothing but ui u sin theta, and your time is actually x divided by u cos theta plus, right, half into ay is minus g, t square is again, what is t square? Which is x divided by u cos theta square, right? So your u cancel, sin theta by cos theta is nothing but tan theta. So x tan theta, your equation of motion is going to be x tan theta minus, right, half into g into x divided by u cos theta whole square. Simple, guys, right? we have written it in the proper expression, which is y is equal to ut plus of at square, right? So this is your equation of trajectory. You want to know where the particle is, give me the value of time, you get y. Y corresponds to a particular value of x. That's all. That is your equation of trajectory, right? So we have seen all these things, right? But in case of, right, looking at the practicality, if I want to change vectors, if I want to change projection angle, right, so things are going to change, right? We will classify that factors influencing the projectile motion, velocity of release, ಎಷ್ಟು ಜೋರಾಗಿ velocity of release ಮಾಡ್ತಿದ್ಯಾ, ಎಷ್ಟು ಜೋರಾಗಿ ಬಾಲ್ನ ಎಸೆತಿದ್ಯಾ, ಡೆಫಿನೆಟ್ಲಿ ಅದ್ರ ಮೇಲೆ ಟ್ರಾಜೆಕ್ಟರಿ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, ರೈಟ್? ಜೋರಾಗಿ ಎಸೆದ್ರೆ ದೊಡ್ಡ ಇದಾಗುತ್ತೆ, ಇನ್ನು ಜೋರಾಗಿ ಎಸೆದ್ರೆ ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಬೇಸಿಕಲಿ ನಿನ್ನ ಟ್ರಾಜೆಕ್ಟರಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂತ ಪಾಯಿಂಟ್, ರೈಟ್? ಆಂಗಲ್ ಆಫ್ ರಿಲೀಸ್ ಯಾವ ಆಂಗಲ್ ಅಲ್ಲಿ ಎಸೆತಿದ್ಯಾ ದಟ್ ಆಲ್ಸೋ ಮ್ಯಾಟರ್. ಗೋಡೆ ಪಕ್ಕ ನಿಂತ್ಕೊಂಡು ಬಾಲ್ನ ಎಸೆದ್ರೆ ಬಾಲು ವಿಲ್ ನಾಟ್ ಕ್ರಾಸ್, right? You have to come back and throw the ball, right? Your angle of release and point of projection, all these things are going to matter when you look at projectile motion, right? So let us just recall the things we have just now derived, which is time of flight, right? This is time of flight, right? You have maximum height, h, and then we derived range, and then this is your equation of, right, trajectory of the projectile. So all are the things we have seen and derived are on the screen, right? So instead of throwing it from the ground like a rich guy, you want to throw it from the top of a building, right? In that case, that too, you are throwing it with complete horizontal velocity, right? You are only not throwing in this direction, you are throwing the ball in complete x direction, right? So that is going to be your horizontal projectile. A projectile thrown from a certain height in completely along x direction is called horizontal projectile, right? So I threw the ball with a certain velocity, let us say u, in complete x direction, right? Initially uy 0 irutte because ux is complete u, right? And because of acceleration ball ಕೆಳಗಡೆ ಬರುತ್ತೆ ಅಲ್ವಾ, ಸೊ ಗ್ರೌಂಡಿಗೆ ರೀಚ್ ಆಗುತ್ತೆ ಬಾಲ್ ಬಿಕಾಸ್ ಆಫ್ acceleration, because your vy is going to increase with acceleration. So this is the trajectory. But if you want to analyze the motion which is happening along y axis from second equation of motion, right, y is going to be uy t plus of ay t square from the topmost point till this point, right? So in that case uy t, initially what is uy? It is 0. So uy t, this term is 0 into t plus half into ay is minus g times t square, right? So this is your y. Y is going to be what? See, you have thrown the ball from topmost point till the ground. The ball has moved down. If this is your plus, right? If this is your upwards is plus and downwards is negative, upwards is plus and downwards is negative, right? Your y has actually gone down, so it is going to be minus y, right? So or we call it as height h, minus h, right? So I substitute the values here, minus h. So your g minus this minus gets cancelled, so you have from this equation t is, if you just rearrange, t is going to be 2, right? 2 h times divided by g under the root. You have the expression. It is simple math, right? Do it along x axis, right? After finding t in terms of h, right, along x axis from second equation of motion, again x is going to be ux t plus of x t square. There is no acceleration in x direction. This term is directly 0. Your range, right, the range which is the particle covers in this motion along this direction, right, from here till here is going to be simply ux times, right, t, right? T is 2h by under root 2h by g. You have u, which is the initial velocity. Clear guys? Horizontal projectile andrenu? A projectile thrown from a certain height in completely along horizontal direction, right? Can I make variation? Yes, we can make variation. What are the types of variation? I talk, right, projected with an angle theta above the horizontal, right? They are saying this time it's not completely along x direction, we are giving it some top inclination, right? So this time, what is the process? What is the process? If a vector is given with a particular axis which is not along your x and y, what do? We resolve and throw it away, right? We resolve and throw it away. Resolve it along x direction, it's going to be u cos theta. Resolve it along y direction, it's going to be u sin theta, guys, right? So our resolution is done, right? Projected along this direction with theta angle, right? From second equation of motion, your y is going to be uy t plus of ay t square, right? Ay t square. What is uy going to be, guys? Whatever it is, ball goes and comes back, right? So your uy, right, y is nothing but again minus h only. It's not going to change. Ball esthid ball yavattu kelag bande barutte, so it's going to be minus h. uy t enide, uy enide, u cos theta ide, time bandbitu t ide. So your, what is this? Your plus into of ay enide minus g ide, so times t square, right? You solve this expression, we get a value of t, right? You solve this expression, we get a value of t. So that t is going to be, right, substituted in this second equation of motion along x. So your x is going to be uxt, right, plus of x t square. What is ax? Sorry. So this should have been, see, this should have been uy, right? This should have been u sin theta. Actually this is correct, this is u sin theta, right? I made a mistake. This is u sin theta, and your ux is nothing but right, u cos theta times t. This term is going to be 0 because ax is 0. You get a value of t, substitute here, you get the range for a projectile which is thrown with an angle theta above the horizontal. Process remains same, right? Given vector, resolve it along x and y, and you apply equations of motion along x and y independently, right? So similar variation, projected with an angle theta below the horizontal, right? This time angle theta is here, right? Vector is thrown, a ball is thrown in the downward direction, in this direction, right? Again, u along x direction is going to be u cos theta, u along y direction is going to be u sin theta, right? So again, always g is acting downwards, right? From second equation of motion along your y axis, y is equal to uyt plus of ayt. y ಏನಾಗುತ್ತೆ, ಬಾಲ್ ಟಾಪ್ ಇಂದ ಕೆಳಗಡೆ ಬರ್ತಾ ಇದೆ, ರೈಟ್? ಯಾವುದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೊಸಿ ಬಾಲ್ ಗ್ರೌಂಡಿಗೆ ಬಂದೇ ಬರುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ this height is going to be minus h, because the ball has come down. In our plus is upwards is plus and downwards is negative system ಅಲ್ಲಿ ball has come down. So which is your h is going to be y is going to be minus h. uy ಏನಿದೆ, uy ಬಂದ್ಬಿಟ್ಟು minus u sin theta ಇದೆ, because it is in the downward direction this time, right? And plus of into ay ಏನಿದೆ, again g is downwards, guys, right? This is going to be minus g times t square. Again, now you solve this equation of like quadratic equation, right? You are going to get the value of t, right? I'm just telling you, these things are not needed for your board exam, right? These things you don't have to remember, right, thoroughly. You don't have to by heart these things. You have to have an idea of how to derive these things. There is nothing special I'm teaching here, right? All the same things. I'm only taking a complication, a small deviation from the ideal case, right? You don't have to mug up these things. You don't have to by heart these things. Just look at the process of these things being solved, right? These may look bigger for you, but the problems are simple because the process is simple, right? So your t is going to be something. You apply second equation of motion along x. Again, x is equal to uxt plus of ax t square, right? So x is, again, this term is 0. So your x is nothing but the range that the particle covers in this type of a setup, right? Particle covers this range. This is your range, right? So sorry, the range is from where to where? It's not just this much, right? This range is actually, right, from the wall till that point, okay? This range is from here to here. There was no space, that's why I've written minus h here. I got confused, that's all, right? So your range is u cos theta times t. Okay, then these are the things for an horizontal projectile, right? So now let us change the situation, right? You have a person, right? You have a person, right, standing in front of a ಒಂದು ಬೆಟ್ಟದ ಮುಂದೆ ನಿಂತ್ಕೊಂಡು ಬಾಲ್ನ ಎಸೆತಿದ್ದಾನೆ, right? This betta is having an inclination alpha with the horizontal, right? Now you want to know how much time it takes for the particle to land here, and right, how much like distance it will travel in that direction, right? How much height it will go. All these things let us try to derive in this type of a setup, right guys? Our horizontal regular x and y axis are always along this direction, right? Now what I do is I rotate my x axis, regular x axis ಏನਿತ್ತು ಅದನ್ನ rotate ಮಾಡ್ತಾ ಇದ್ದೀನಿ, right? ಯಾಕೆ? Because I want to treat this horizontal surface as my new x axis. If I do that, are the things going to change? No. If you change math, nature is not going to change. If you change math, physics is not going to change, right? You could have solved, but for simplicity, I am turning my coordinate axis x and y in this direction, right? So I am defining my new x and y axis, right? So this is your new x axis and this is your new y axis. Why I did that? ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ ಯಾಕೆ ಅಂತ. ಬಟ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಿಂತ್ಕೊಂಡು ಬಾಲ್ನ ಎಸಿತಿದೀಯಾ ಅಂದ್ರೆ, ಸೊ ಅಟ್ ಅನ್ ಆಂಗಲ್ ಥೀಟಾ ವಿತ್ your inclined surface, it's not from the previous x axis, inclined surface ಇದೆಯಲ್ಲ ಅಲ್ಲಿಂದ ಥೀಟಾ ಇದೆ, right? So your u is this vector, right? Whenever we have coordinate axis and a vector with a certain angle, what do? We always resolve the vector, right? So let us resolve this u vector along this direction, along new x axis, right? It is going to be u cos theta. Along y direction, in this direction, your u is going to be u sin theta. This time g is not in your minus y axis. G also we need to do what? G also we need to resolve, right? Your standard x and y axis are not along g. Why? Because for simplification only, you'll understand, right? So your g is in this direction. Now this angle is alpha. What is this angle going to be? Because this one and this one are perpendicular to each other, so this is going to be 90 minus alpha. If this is 90 minus alpha, this angle is going to be alpha. So your g, right, in this component going to be direction going to be g sin alpha, and this one is going to be g cos alpha. What did we do here? We just defined new x and y and we resolved our g and u along those two new axes using the angle alpha and theta, right guys? Let us tabulate that data, right? You have u along x axis, which is u cos theta, and u along y axis, which is which direction? U along y axis, right, which is u sin theta, right? U sin theta. Acceleration now along x axis is going to be, x axis alli g sin alpha ide, but it is in opposite direction, so it is g sin alpha, right? Along y direction it is g cos alpha. This is also minus, guys. Now you have two components of acceleration, which means both the components of velocity are going to change because you have both the components of acceleration. Previously acceleration in x was not present, but since you have new x axis, so things are going to change here, right? So what do? We'll analyze the motion. We will try to jump from, right, too much of math, too much of vectors into the results of physics, right? What do we do? First, from the projectile on an inclined plane thrown from the bottom of a inclined, right, surface till the top here, what do? We want to calculate time of flight, right? ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗೋಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತು ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ along y axis, along my new y axis, I am going to apply second equation of motion, which is y is equal to uy t plus of ay t square na apply ಮಾಡ್ತಾ ಇದ್ದೀನಿ, right guys? Particle started from origin, right, and came to this point. What is happening? The particle is going from here on the x axis coming back to on the x axis. Is there any change in y? Particle is still along x axis, there is no change in y, so y is going to be 0. What is uy? Uy is your velocity along y direction, that is u sin theta. Let us call the time taken is total time, which is time of flight, which is capital T, of what is ay ಏನಿದೆ ಇಲ್ಲಿ? g cos alpha ಇದೆ, in which direction guys? Minus y direction, so it is going to be g minus sine alpha times capital T square guys. So your right hand 0 ide, so minus term na ikade tagantini, so of g sine alpha t square is going to be equal to u sine theta times c t, right? Did we do it correct? Did we do it correct? Our y component is g cos alpha, right? This is g cos alpha, not g sine alpha. This is actually g cos alpha. This is actually g cos alpha. G cos alpha. Y aliro acceleration g cos alpha, which is minus. Okay, so you have g cos alpha here, right? I am rewriting this expression, right? You have g cos alpha, so your of g cos alpha t square, right? T square, which is equal to u sine theta times t. 1t gets cancelled, right? You have total t, capital T, time of flight, which is going to be equal to 2. E 2 na illi kadastidini, 2u sine theta by your cos alpha goes down with what? With g. So this is your time of flight, guys. Previously, when there was no horizontal, right, wedge ilde iddaga time of flight enittu 2u sin theta by g ಇದೆ. ಬಟ್ ದಿಸ್ ಟೈಮ್ ಒಂದು ಕಾಸ್ ಆಲ್ಫಾ ಟರ್ಮ್ ಎಕ್ಸ್ಟ್ರಾ ಬರ್ತಾ ಇದೆ, ಯಾಕಂದ್ರೆ ನಾವು ವೆಕ್ಟರ್ ಅನ್ನ ರೊಟೇಟ್ ಮಾಡಿದೀವಿ, ಆರ್ ಕೋಆರ್ಡಿನೇಟ್ ಆಕ್ಸಿಸ್ ಅನ್ನ ರೊಟೇಟ್ ಮಾಡಿದೀವಿ ಬೈ ಅನ್ ಆಂಗಲ್ alpha, because we wanted to treat this horizontal surface as your x-axis so that we can quickly get the solution. We could have solved by considering previous scales also. That's a little complication, we avoided it. Time of flight is done, right? Let us now look at the maximum distance that it moved along y-axis, right? It moved along y-axis, right? ಎಸ್ದಿದ್ ಬಾಲು ಇಲ್ಲಿಂದ ಎಸ್ದಿದ್ ಬಾಲು ಈ ಟ್ರಾಜೆಕ್ಟರಿನ ಫಾಲೋ ಮಾಡ್ತಾ ಇದೆ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ not symmetric motion about this line, because you have a wedge here, the motion only stops here. This is not a symmetric part. I could have not said time of flight illige hogi time of ascent is equal to time of descent anta ಹೇಳಕ್ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ particle is now having not symmetric motion, right? But this time we are calculating the distance that it moved along your y axis, which is y maximum, right? We are calculating y maximum. How do we calculate that, guys? See, along y axis from third equation of motion we are trying to apply third equation of motion. V square is equal to u square plus 2a y, but y components, right? At the topmost point again the particle is not further moving anything up by even a centimeter also, right? So that is because your y component, right, at that point velocity y component at that point is 0, right? So we can apply that here 0. Y at the topmost point is 0, so your uy is going to be u sine theta, so it is going to be u sine theta square plus 2 into ay enide, this is your ay, so ay enide again g cos alpha ide, which is minus g cos alpha, because that is minus axis alva. So your y, which is y maximum, right? So now minus term na ikade ತಗೊಂಬರ್ತೀನಿ, 2g cos alpha equal to u square sin square theta, guys, right? So times y m times y m. Now you send this 2g cos alpha term down, right? You have this expression u square sin square theta by 2g cos alpha. Now again look at this expression, guys. Previously we had maximum height h is equal to u square sin square theta divided by 2g ಅಷ್ಟೇ ಇತ್ತು. Now cos alpha term ಬರ್ತಾ ಇದೆ, ಯಾಕೆ ನಾವು ವೆಕ್ಟರ್ ನ ರೊಟೇಟ್ ಮಾಡಿದೀವಿ, ನಮ್ಮ ಕೋಆರ್ಡಿನೇಟ್ ಆಕ್ಸಿಸ್ ನ ರೊಟೇಟ್ ಮಾಡಿದೀವಿ. That is why this cos alpha term is going to be existing here, right? So our maximum height in that case is clear. Now let us look at the range. ಎಸ್ದಿದ್ ಬಾಲು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ದೂರ ಟ್ರಾವೆಲ್ ಮಾಡ್ತು ಅನ್ನೋದನ್ನ ನಾವು ರೇಂಜ್ ಅಂತ ಕರಿತಿದೀವಿ. ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇಫ್ ಐ ಅಪ್ಲೈ ಸೆಕೆಂಡ್ ಈಕ್ವೇಶನ್ ಆಫ್ ಮೋಷನ್, ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಎಕ್ಸ್ ಟಿ ಪ್ಲಸ್ ಆಫ್ ಎಕ್ಸ್ ಟಿ ಸ್ಕ್ವೇರ್, ರೈಟ್? ದಿಸ್ ಇಸ್ ಯುವರ್ ಟಿ ಸ್ಕ್ವೇರ್. ಸೊ ಟಿ ಸ್ಕ್ವೇರ್ 2 ಸೊಟ್ಟ ಆಯಿತು ಟಿ ಸ್ಕ್ವೇರ್, ಸೊ ಅಗೇನ್ ತಪ್ಪಾಯಿತು. correct everything 2 square, right? So here x is nothing but range, because that is what we are naming it as, plus r, which is equal to ux ಏನಿದೆ u cos theta ಇದೆ, u cos theta ಇದೆ, times t ಏನಿದೆ total time of flight, right? This is because the particle is going from here to here, time of flight, plus half into x ಏನಿದೆ x g sin alpha ಇದೆ, which is minus g sin alpha, ಯಾಕಂದ್ರೆ ಅದು minus axis t square. Again guys, now we have the term t, time of flight, last slide ಅಲ್ಲಿ ನಾವು derive ಮಾಡಿದ್ವಿ, which is 2u sin theta divided by g sin alpha. ಇದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡು, ಈ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟಿ ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡು, ರೈಟ್? ಈ ಕ್ವಾಡ್ರಾಟಿಕ್ ಇಕ್ವೇಷನ್ ನ ಸಾಲ್ವ್ ಮಾಡು, ರೈಟ್? ಕ್ವಾಡ್ರಾಟಿಕ್ ಇಕ್ವೇಷನ್ ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ನಮಗೊಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಫ್ ಆರ್ ಬರುತ್ತೆ, ದಟ್ ಈಸ್ ಯುವರ್ ಸೊಲ್ಯೂಷನ್ of the above, right? Because I'm not doing, because you don't have to remember these things, but the process is very clear, right? You have second equation of motion along x-axis, and you know time of flight 2u sin theta by g sin alpha, substitute it here, so you are going to get the value of r in terms of theta, u and g, right? That's all, right? So we have now studied about a projectile on an inclined plane thrown from bottom till the topmost point. I'll give you one interesting problem, another case of this projectile motion which is thrown from top to bottom ಇಂದ ಎಸ್ದಿರೋ ಬಾಲ್ ನ ಅದೇ ಸೇಮ್ ಪ್ರೊಸೆಸ್ ಅಲ್ಲೇ ನಾವು ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್, ರೇಂಜ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಟ್ರೈ ಮಾಡಿ, ಸೇಮ್ ಪ್ರೊಸೆಸ್ ನ ಫಾಲೋ ಮಾಡಿಕೊಂಡು ಈ ಮೂರು ಥಿಂಗ್ಸ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ. What are we doing? We are gonna rotate our y and x axis along this new horizontal, same process, resolve the component u into this axis, u cos theta, u sin theta, and g into this axis, g sin alpha and g cos alpha ಮಾಡ್ಕೊಂಡು ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್, ರೇಂಜ್ ನ ನಾವು ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಯಾವ ತರ ಮಾಡಿದ್ವೋ ಅದೇ ತರ ಮಾಡ್ಕೊಂಡು ನಾವು ಫೈಂಡ್ ಮಾಡಬಹುದು. ಸೊ now let us start solving some problems based on the things we have studied so far, right? We have studied a lot of things, which is a projectile, and we studied horizontal projectile, and then we studied about inclined plane projections also, right? Based on all these things, we'll try to solve some simple problems na solve madana, right? You have a ball thrown by one player, reaches the other in 2 seconds, right? You have a ball thrown from one player to another player, reaches in 2 seconds, guys. ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ 2 seconds ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಬ್ಲಾಕ್ ಕಲರ್ ನ ತಗೊಂತೀನಿ, ಚೆನ್ನಾಗಿ ಕಾಣುತ್ತೆ, ರೈಟ್? ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ 2 seconds ಅಂತ. ಸೊ ಯುವರ್ ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್ ಇಸ್ 2 seconds, right? The maximum height attained by the ball above the point of projection will be, we need to calculate maximum height, guys. So maximum height h ಏನಿರುತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. We know the formula for time of flight. Time of flight is going to be ಏನು 2u sin theta by g. If this is your, right, if this is your, right, ಈ ಪ್ರೊಜೆಕ್ಷನ್ ಅಲ್ಲಿ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಥೀಟಾ ಇದ್ರೆ ದಟ್ ಇಸ್ your 2u sin theta by g, and maximum height h ಫಾರ್ಮುಲಾ ಜಸ್ಟ್ ರೀಕಾಲ್ ಮಾಡಿ, ನೋಟ್ಸ್ ಓಪನ್ ಮಾಡಿ, u square sin square theta by 2g, right? Guys, here t is given as 2, so I substitute here 2, right, is equal to 2u sin theta by g. 2 cancel ಆಯಿತು. You have your u sin theta, right? u sin theta is equal to g, right? u sin theta is equal to g. Now substitute that here back to your maximum height. H is going to be, u sin theta is nothing but g, so your h is going to be g square by 2g. g cancel ಆಯಿತು, so it is just g by 2. What is g? In general, in SI, our value of g is 10, so it is maximum height is going to be 5 meter, right? So you know the time. ಇಲ್ಲಿಂದ ಅಲ್ಲಿಗೆ ಎಸೆಕ್ಕೆ 2 ಸೆಕೆಂಡ್ ಗೊತ್ತು, 2 ಸೆಕೆಂಡ್ ಅಂತ ಗೊತ್ತು. Now you are able to calculate maximum height ಎಷ್ಟು ದೂರ ಹೋಯಿತು ಅಂತ ಹೇಳ್ಬೋದು, right? Maybe this is the principle that things have been applied, right? Quickly calculate things using speedometer, all these things in fancy cricket stadium, they'll immediately give the value of, right, horizontal range, and maximum height, right? ಎಷ್ಟು ದೂರ ಹೋಯ್ತು 6, ಎಷ್ಟು ಎತ್ತರ ಹೋಯ್ತು 6, ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತು, ಎಷ್ಟು ಇಂಪ್ಯಾಕ್ಟ್ ಇದೆಲ್ಲ ಕ್ವಿಕ್ ಆಗಿ ಬರುತ್ತೆ, ರೈಟ್? ಡೆಫಿನೆಟ್ಲಿ ದೀಸ್ ಆರ್ ದ ಬೇಸಿಕ್ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಬಿಹೈಂಡ್ ದಿಸ್, ಬಟ್ tech is being involved in getting the quick solution to these things, right? Second problem, a bomb is dropped from an airplane flying horizontally, right? Airplane ide horizontally fly ಆಗ್ತಾ ಇದೆ, horizontally fly ಆಗ್ತದೆ with a velocity at an altitude of 980 meter, guys. This distance altitude is 980 meter. The bomb will hit the ground after a time, right? ಈ ಹೋಗ್ತಾ ಇರೋ ಹಾರಿಜಾಂಟಲ್ ಹೆಲಿಕಾಪ್ಟರ್ ಇಂದ what are we doing? We are dropping a bomb, right, in this direction. Because the bomb is dropped from a moving aeroplane, bomb will have its velocity, right, which is equal to the velocity of the plane, because it is just dropped from the flying aeroplane. So you have u, which is same as the velocity of your airplane, right? So it covers 980 meters in a particular time. We need to calculate that time, guys. So what are we going to do? We are going to apply, right, our second equation of motion along which direction? We are going to apply it along y direction. So u y, right, uy times t plus half into ay times t square. So your u y, which is initially, was there any velocity? No, there was no velocity. 0 times t plus half g enide, right, ay enide minus 10 ide, because it is in downward direction, right? So minus 10, which is t square, right? And y enide, again, see guys, your g is downwards, displacement ಬಾಂಬು ಎಸ್ದಿದ್ ಬಾಂಬು, ರೈಟ್, ಕೆಳಗಡೆ ಬರ್ತಾ ಇದೆ, ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ಇಂದ ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಇದೆ. ಸೊ ಯುವರ್ y's displacement is actually going downward. That is why your y is minus 980. This minus that minus gets cancelled. You have t square, right, which is equal to this one times the 3 t square is equal to 980 by 5. 980 by 5, which is going to be equal to, guys, 196. You take that value, this t is going to be 14 seconds. A square root ತಗೊಂಡ್ರೆ ನಮಗೆ 14 seconds ಅಂತ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಎಸ್ದಿದ್ ಬಾಂಬು 14 seconds ಅಲ್ಲಿ ಕೆಳಗಡೆ ಬರುತ್ತೆ, right? So second problem is done. Next problem ನ ನೋಡೋಣ, right? So for an object thrown at 45 degree with the horizontal, the maximum height and the horizontal range are related as. You need to get an expression between maximum height and horizontal range. See guys, they are saying that, let me change the ink, right, to yellow, right? They are saying that a body is thrown at a 45 degree angle, right? This theta is equal to 45 degree. So you need to relate maximum height and range. First of all, how do we write maximum height? Maximum height u square sin square theta by 2g. This is the formula, right? We just now derived in the last few slides, right? And your maximum height is that, and horizontal range r is going to be u square sin 2 theta by g. Guys, if theta is equal to 45 degree, if theta is going to be equal to 45 degree, right, if theta is 45 degree, sin theta is going to be 1 by root 2. So this sin 45 is actually 1 by root 2, right? Now let us apply that value here. H is going to be equal to u square sin square theta, u square sin square theta, sin square 45, which is sin square 45, which is 1 by root 2 square divided by 2g. Similarly, r is going to be u square sin 2 theta. Theta is 45 degree, so 2 theta is going to be 90 degree. So which is sine of 90 degree. So this is sine of 90 degree by g. Sin 90 is 2, sin 90 1. So your r is actually u square by g ide guys, right? So r is actually u square by g ide, right? Here from this one I write an expression for u square, right? U square is simply r times g. Now I come back and substitute it here. So here h is going to be u square is nothing but r times g, and 1 by root 2 square is nothing but 1 by 2. So you have 1 by 2, sorry, you have 2 in the denominator, and g there again you have 1 by 2. So g gets cancelled. So your h is going to be r by 4, or your r is going to be 4h. Your h is going to be r by 4, or r is going to be 4h. This is the relation between maximum height h and horizontal range r, right? Clear everybody, right? The problem was very simple. Now let us look at the fourth problem, which is again based on projectile motion. A projectile is thrown at an angle beta. So each time careful agirbeku with the vertical, not horizontal. Initially, right, we used to take it as horizontal, but they have given it as vertical, right? You are throwing a projectile with an angle, right? With an angle beta with the vertical, guys. You have to be careful. It reaches a maximum height, and the time taken to reach the highest point of its path in terms of h and g. You need to calculate, right? What do we need to calculate? The time taken to reach highest point ge reach agake ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಟೈಮ್ ಆಫ್ ಲೈಟ್ ಏನಿದೆ? ಫಾರ್ಮುಲಾ ಏನಿದೆ? ಟೈಮ್ ಆಫ್ ಲೈಟ್ t is going to be equal to 2u sin theta by g ide, right? This is your theta. If this is the theta, time of flight 2u sin theta by g. But what is theta, guys? Theta is nothing but actually 90 minus beta, right? So your time is actually nothing but 2u sin theta, which is 90 minus beta by g. But when you throw a projectile like this, it covers a range, right? It covers a range. In covering that range, time taken is time of flight, but we are asked to calculate to reach the highest point, right? So since it is symmetric, your t, right, time taken is actually t by 2, right? That's what we did. When we calculated time of flight, we have added time of flight as time of ascent plus time of descent. So time taken is actually t is going to be t by 2, right? So we will write t as t by 2. But what is t? 2u sin 90 minus beta. 90 minus beta is nothing but cos beta, right? Which is 2u cos beta divided by 2g. So this is your time. Remember it, t is going to be equal to 2u cos beta by g, right? What did we derive? So t is 2u cos beta divided by 2g. 2 cancels, which is t is going to be 2u cos beta divided by g. But your time of flight, right, time which is taken from going from origin till the topmost point should be expressed in h. They have explicitly mentioned, guys. So what is h going to be? Horizontal range, we derived formula, h is going to be u square sin square theta divided by 2g, right? What is theta? 90 minus beta, so which is going to be u square sin square of 90 minus beta divided by 2g. Sin square 90 minus beta is cos beta, so we can write it as u square cos square beta divided by 2g. This is your h. U cos beta divided by g is what? U cos beta divided by g is actually your t. So you can write u cos beta divided by g jagadalli, right? Or here, instead of doing that, you can write u cos beta is equal to tg, right? Let us directly substitute it here. So u cos beta tg, so t square g square divided by 2g. This is h, right? H. Here G 1G gets cancelled, 1G gets cancelled. So your T square times G by 2 is H. So what is T going to be? So I send this to this side. So 2 H by G under root. That is your T. Time taken to go from, right, here till here. Here till here. This is your T. Right? Let us solve the next problem. The horizontal range of a projectile is 4 root 3 times the maximum height. They are saying R is equal to 4 root 3 times maximum height H. This is the given data. Its angle of projection theta will be, straightforward question, theta ಏನಿದೆ, range ಎಷ್ಟಿದೆ, theta ಏನಿದೆ, range HL ಕೊಟ್ಟಿದ್ದೀನಿ, theta ಏನಂತ ಹೇಳು. So guys, formula ಗೊತ್ತಿರಬೇಕು. R ಏನಿದೆ, R is U square sin 2 theta divided by G, and our H is actually equal to U square sin square theta by 2G. So using this given inequality, let us write it. So U square, right, U square, right, U square sin 2 theta by G ಏನಿದೆ equal to 4 root 3 times H ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. H ಏನಿದೆ, U square sin square theta divided by 2G. ಇಲ್ಲಿ U square cancel, G cancel, 2 1s are 2, 2s are. But your sin 2 theta is nothing but 2 sin theta times cos theta, and you have on the right hand side root 3 times sin theta square, which is nothing but sin theta times sin theta. 1 sin theta gone. So you have sin theta by cos theta, right, sin theta by cos theta, and this 2 is also going to get cancelled, nah? Right, you have sin theta by cos theta on the left hand side, which is equal to 1 by root 3, right, which is equal to 1 by root 3. Sin theta by cos theta is nothing but tan theta. So if tan theta is equal to 1 by root 3, theta is going to be directly pi by 6, correct? So you have got the answer for this one also. Today we have solved a set of 5 problems based on projectile motion, right, which is time of flight, maximum height, range of projectile. We have not solved problems based on inclined plane, horizontal projectile. These things have been given in your DPP. Go try and solve those problems. Only when you apply and try to get the answer, you will understand better, right? So in next class, I'll come up with the next lecture of motion in a plane. We will wrap up motion in a plane in that lecture, and you have to keep working on your DPP. Guys, thank you for watching. I'll see you in the next class. Okay.